Today we're looking at finding intervals of concavity and points of inflection using the graph of f prime of x. So before we do that, let's remind ourselves what we used the graph of f prime of x to do yesterday.
Critical points.
To find critical points, and how do we use the graph of f prime of x to find critical points? Where it touches the x-axis. Where it's undefined, where f prime of x is undefined. So that's where we got the critical point from. What else did we use f prime of x to get? Relative extrema. And how do we do that?
Where it changes from negative to positive and vice versa.
Where what does?
The graph.
Where f prime of x changes from negative to positive or positive to negative, that gives me relative extrema. Okay, what else can the graph of f prime of x tell me about f of x?
Points of inflection.
We'll get to that today.
There is increasing or decreasing.
Where f is increasing or decreasing, and then how does it tell me that, Brady?
If f prime of x is positive or negative.
Very good. So if f prime of x is positive, that means f of x is increasing. If f prime of x is negative, that means f of x is decreasing. Very good. So that's everything we know from the derivative graph so far. Today, though, we're going to add intervals of concavity and points of inflection. So we're going to be able to find that as well from the first derivative. So as you can tell, there's a lot of stuff we can get from the first derivative. Okay?
Yeah.
And yesterday we were talking about the function above. So since we were talking about the function above, what was it we were interested in on f prime?
Whether it's positive or
There you go, whether or not it was positive or negative. Okay, today we're really going to be talking about what it tells me about the function below, so we're interested in where it is increasing or decreasing, so keep that in mind. Alright, so the first thing I want to do is explain what concavity is. There are two different types of concavity. Those two different types of concavity are concave up and concave down. This particular graph that you don't have, this is the graph of f of x, by the way, on the board. So this is what f of x would look like, and this thing is a certain concavity from here to there, and from about here to there. That's one type of concavity. And the other type of concavity would be from here to there, and from here on up. Okay. So those are my two different types of concavity. What do you think the green type of concavity is? If you were going to describe it.
Convex.
No, it's got concave in its name. Concave down or concave up are your two choices. And the green is concave down. We'll talk about it in just a second. So the green is concave down, which means the yellow is concave up. Okay, and I'll tell you a dorky thing I told third hour, but it may help you, it may not. Concave down looks like a crown, and concave up like a cup. So concave up like a cup, concave down like a crown. So that may or may not help you. I don't necessarily like it, but it'll get you there.
Yeah, you don't like shortcuts.
It's not necessarily shortcuts. I don't like crutches. I don't like crutches. So, we said today we're going to use the first derivative to talk about the second derivative, because the second derivative is what tells me. The second derivative is what tells me whether or not I'm concave up or concave down. If the second derivative is greater than 0, which means if the second derivative is positive, we are concave up. So if the second derivative is greater than 0, that gives me concave up. If the second derivative is less than 0 or negative, it is concave down. So where it is green, I know that my second derivative is what? Negative, and where it's yellow, I know my second derivative is positive. Okay? Now, the points of inflection. Points of inflection are the locations where your graph changes concavity, where it changes from concave up to concave down, or concave down to concave up. So where does that happen here? Obviously, this spot, and that spot. Those are my points of inflection. The locations where you change concavity. So how can I use the second derivative to tell where I'm going to change concavity?
Where the second derivative equals 0.
Equals 0 and does what?
Changes sign.
Changes sign. So where the second derivative changes sign, that's where you have points of inflection. Okay? But this is all using the second derivative. But what are we going to use today? We're going to use the first derivative. Okay? So if I'm going to use the first derivative, how am I going to be able to use the first derivative and determine whether or not I'm concave up or concave down?
Whether it's positive or negative.
Nope.
Increasing or decreasing.
Yes. Because if the first derivative is increasing, that tells me my second derivative is positive. So this right here happens when f prime of x is increasing, and this right here happens when f prime of x is decreasing. So what's going to happen at points of inflection if I'm using the first derivative?
Points will change from increasing to decreasing.
F prime of x is going to change from increasing to decreasing, or
Decreasing.
decreasing to increasing. So that's what we're going to use the first derivative for today. So back on what we took notes with yesterday, we're going to go back through those same graphs, and this time we're going to do concavity, intervals of concavity, and points of inflection. So on the first one here,
No.
what can you tell me about intervals of concavity?
None.
There are no intervals in concavity. Why?
It never changes from increasing to decreasing.
That's points of inflection. I wanted to know concavity first. Is there any concavity to this problem?
So relative extreme.
No.
There's no frown.
It's a line.
There's no frown or cuts.
But we're not looking at f of x. You guys are thinking about f of x. We're now looking at f prime of x. So if I'm looking at f prime of x, what is it I'm looking for to determine concavity?
Whether it's increasing or decreasing.
Where it's
Whether or not it's increasing or decreasing. And what's going on with this first one? It is not increasing, it is not decreasing, which means there is no concavity on this first one. So there is no concavity on this first one because it's not increasing or decreasing. What about the second one?
Increasing.
It is increasing. F prime of x is increasing, which means what?
Concave up.
We are concave up. So our interval would be -5 to 5. We are concave up. How do I know I'm concave up?
F
X
prime
is increasing.
F prime of x is increasing.
Do we have to justify?
On points of inflection, you got to justify the points of inflection. So, are there any points of inflection on B, and why or why not?
No.
No. Why are there no points of inflection? F prime of x is always increasing. What has to happen to have a point of inflection?
change from directions. Change from increasing.
Right, it has to change from increasing to decreasing or decreasing to increasing. This one is always increasing, which means it's always concave up. What graph do you know is always concave up?
An upside down parabola.
A lie.
An upside down parabola would always be
So
concave down.
parabola.
So a parabola is always concave up.
Okay.
So you know the second derivative of parabola is always the second derivative,
Positive.
positive, and the first derivative is always increasing. And I know this is a lot to take in, but you'll get it here in a second. I promise. All right, C. Intervals of concavity. Erica, what do you think?
Concave down? I don't know.
You don't know? What are we looking for? Remind me what we're supposed to be looking for.
If it's increasing or decreasing.
Okay, what's this graph doing?
Decreasing? I don't know. It doesn't look like anything to me.
It doesn't?
I can't figure it out.
How do I tell? No, we can't give up, Erica.
Well,
can handle
it's
this.
not obvious because it's not a line going right up.
Alright, so if I start on the left and I'm moving to the right, what is my graph doing as I move to the right, Erica?
It's increasing.
It is increasing. So that means this thing starts out with concave up. So I know from -4 to some other number, I'm concave up. And what is that other number where it stops increasing? Erica. Zero. And after 0, what does it start doing?
Decreasing.
It starts decreasing from 0 to 4, so that means it is concave down.
Okay, well, didn't you say earlier that parabola is always concave up or something?
But that's if it's f of x.
Oh, F.
We're looking at f prime of x.
Okay.
And that's the tough part, is making sure we know which function we're talking about. Pauline?
I say it was just difficult tying in how they all tie into each other.
Right, there's a lot going on with the first derivative. Alright, so, AJ, do I have any points of inflection?
Yes.
Quit helping her. You're hurting her by helping her. I heard somebody. It wasn't you, I know that.
I sneezed. You heard me sneeze. Sounds a lot like an answer.
Yes, or vice versa.
Mami,
So where's my point of inflection? At 0. So I have a POI at x equals 0, and my stamp, just like we had a stamp justification yesterday, what's going to be my stamp justification today on a POI?
Because f prime of x changes from increasing to decreasing.
Because f prime of x changes from increasing to decreasing. What's the other alternative that might say?
Decreasing to
Decreasing to increasing. Whenever we're justifying a POI using the first derivative, that's going to be my justification.
I'm gonna literally make a stamp.
If we use the second derivative, it's going to be different. We'll talk about that in a second.
Well, once you write it.
Alright, next one. Brock, D.
D,
Concavity, intervals of concavity.
from -5 to 1,
-5 to 1. What is it?
concave
Because
because f prime of x is increasing.
because f prime of x is increasing. Very good. Then what?
From 1 to 5,
It is
concave down.
because
F prime of x is decreasing.
POI
1,
because
is it sharp turn?
no.
I don't know.
We just said we got a stamp justification on POI.
Oh, change from increasing to decreasing.
Because f prime of x changes from increasing to decreasing. Very nice, Brock. All right, next one, Justice. You got the next one. E. Intervals of concavity. -4 to 1. What are you saying?
concave down.
I disagree.
Disagree?
I disagree.
Oh. Where would it
Where you at?
What are we looking for again?
be? Concavity.
Okay, what is it I'm looking for? What I'm looking for concavity. Back there in the corner, be quiet.
Where it's increasing and decreasing.
All right, and what does this thing start out doing? When does it stop increasing? At where?
-4.
No.
No, at 3.
Where?
3? -3?
-3. So -4 to -3, I am concave up. So -4 to -3, I'm concave up. All right, then what does my graph start doing?
From -3 to 1, it's concave down.
-3 to 1, I agree with that. Concave down, and what?
1 to 5 is concave.
1 to 5. Concave up. Very good. Okay, what about POIs?
At -3 and 1.
At -3 and 1. So POI at x equals -3 because what?
F prime of x goes from
Don't say goes. Say changes.
changes from increasing to decreasing.
Very good.
At 1 x equals 1 because f prime of x changes from increasing to decreasing.
Very nice. Questions on that one? Alex? Say it again.
Just out of curiosity, are we gonna have graphs where you have to write these and the critical points? So that's a lot of writing.
Good stuff.
No.
Why is this good stuff?
You have to analyze.
Shanine, F, concavity.
Down from -4 to -1.
Why?
Because terminus is increasing.
Listen to what you just said.
Can you say concave down?
You said concave down.
Yeah.
What should you have said?
Oh, concave up.
You should say concave up. Increasing is concave up. So where does it stop increasing?
-1.
I wouldn't say -1. I'd say -2. I like -2 better.
How do we know? Just guess.
It's at the top of the hill. It's going to stop increasing at the top of the hill.
Little gap there.
It looks more like the top of the hill right here than it does over here. It looks like it's going down between these two. If it's going down between these two, then -1 can't be the top of the hill.
Okay.
Do you agree? Do you agree that it's going down between these two?
Yeah, I mean, I'm just saying, like, if.
You'll get
if we're
better.
off by like a
You'll get better. You got the next one. Don't worry.
Oh my God.
So -4 to -2. You said concave what, Shanine?
No, don't worry.
Concave up. All right. Then what do I got?
-2
-2
to 1.
to 1. What are we?
Concave down.
Very good. And
And then from 1 to 3 is concave up.
very good. Points of inflection.
Points of function at x equals -2
-2.
because f of x changes from increasing to decreasing.
All right. Do I have any more POIs? Where?
At 1
Because.
changes from decreasing to increasing.
Very nice. Very nice, Shanine. All right. Alexandria. G.
I already did it.
Too bad.
Okay.
Okay.
That's supposed to be 3.
-3. It's close enough.
-3 to 0.
-3 to 0.
Concave up from 0 to 1.
So what can I say instead of what you said? You said -3 to 0 was concave up, and then you said 0 to 1 was concave up.
Oh. Concave
-3 to 1 on concave up. Why am I concave up? Because f prime of x is increasing. Any points of inflection?
No.
Why not?
There's no change.
There's no change in direction. Good. All right, H, Chelsea.
Concave up from -5 to 1, and concave down from 1 to 5.
Any points of inflection?
X equals 1.
Because
F prime of x changes from increasing to decreasing.
very nice, very nice.
Nice.
Logan,
Yes.
A on the last page. Intervals of concavity.
Concave down. From -5 to 5.
-5 to 5. Any points of inflection?
No,
Why not?
because it's always decreasing.
Because f prime of x is always decreasing. There's no change.
I'll take some.
B, Brady.
From concave down from -2 to 2, and then concave up from 2 to 5
Any points of inflection?
at x equals 2.
Because
F prime of x changes from decreasing to increasing.
outstanding. C, Kaylee.
Concave down from -3 to 0, and concave up from 0 to 2.5.
All right. Any points of inflection?
There's an inflection at 0.
Because
F prime of x changes from decreasing to increasing.
very nice. And D, Pauline.
-2 to 1 concave down. 1 to 5 concave. No. Is it just -2 to 5 is concave down?
Yes. Any points of inflection?
No.
Because
It is because f prime of x is always decreasing.
f prime of x, yes, does not change direction. Very good. All right, so let's write down everything we know we can figure out from the graph of f prime. All right, so what are some things we can figure out from the graph of f prime? Pay attention, please. Concavity.
Points up in
Hold on. Okay, how do we figure out concavity, Alex?
Where's increasing to decreasing?
Okay, increasing slash decreasing gives me concavity. All right, what else?
points of inflection.
Points of inflection. How do I figure that out? Brady.
And the graph of f prime of x changes from increasing to decreasing or decreasing to increasing.
Okay, where it changes direction, meaning increasing to decreasing or decreasing to increasing. What else?
Critical
That's
point.
stuff we didn't.
Critical points. How do I find critical points?
Or F prime of x. Also, because that is the x-axis.
F prime of x touches x-axis or
Or
is what?
undefined.
Undefined. Very good. F prime of x is undefined.
Because-
Pauline.
or there's
So
not
the
one.
first two, the concavity and POI, that describes the second derivative,
Yes, this is really talking about second derivative
and the
information.
other one just talks about the function.
Correct.
Okay.
So this is second derivative info, and everything else we get is first derivative info. So what else can I get?
Relative extreme.
Relative extrema. How, Brock?
Where it crosses the x-axis from decreasing to increasing. Or where it changes from positive to negative or negative to positive.
Okay,
I said that wrong.
so f prime of x changes sign. What else? There's one more thing we can talk about.
I think you're right.
What else can the not one wait for it, yes.
Ask and
Nope.
vertical tangent.
No, what else can the first derivative tell me about the what else?
That's it.
Positive or negative.
What does that mean?
The function below shows whether the function above is positive or negative.
No. You're saying it backwards.
F of x is positive or negative.
Yes.
Function of,
Yes.
oh, in, yeah.
We got there.
Who said that?
Okay, so this is everything we can tell from the first derivative. We can figure out concavity by looking at whether or not it's increasing or decreasing. We can figure out points of inflection where it changes from increasing to decreasing or decreasing to increasing. We can get critical points wherever it touches the x-axis or f prime of x is undefined. We can find relative extrema where f prime of x changes sign, and we can figure out when f is increasing or decreasing, depending on if f prime of x is positive or negative.
We can do some